Hello and welcome to today's parent workshop. So my name's Mr. Fag and I'm going to be talking a little bit about how you can help your child remember things. Now, I gave this presentation yesterday and I had a few technical problems, so I'm just re-recording the presentation. But I'd like to start by thanking all the parents who came yesterday, and I hope you enjoy this presentation. So I'm going to start by introducing myself. Right, let me just share my screen. So I've been working at the school for about 6 years now, and I've been teaching for 25 years. So most of that time has been in primary schools. I've been a maths and English coordinator and a year group leader, and I'm also the school's current science coordinator and a specialist science teacher. I work with the children in years 3 and 4. You may know me from Chess Club. We got quite a healthy group of children, healthy numbers of children playing chess at school. And I have a child in year 5 and year 6. And you may know my wife as well. She works in the uniform shop. I also have 2 education-related master's degrees, and the reason I'm sharing that with you is because some of the research that I'm going to be sharing with you is things that I've studied on various courses in the past. So what are we doing today? So we're going to start by looking at what thinking is and looking at a model of thinking. After that, I'm going to talk a little bit about why facts and knowledge are very important for your child. We're going to look at the term retrieval practice, and then we're going to look at some ways in which you can help your child to remember things at home, and hopefully there'll be a few takeaways for you. Why am I doing this? Well, our school has one of its targets for its school development plan to use cognitive principles and research as a major goal and a major focus. What that means is that we use evidence particularly from cognitive science, which is a science of the mind, to help our children learn. I'm hoping that this presentation will be useful for you, and I'm going to ask for some help at the end. There's just a very short questionnaire, and I'd be grateful if you could fill it in. It will just take a minute, and that will help me with some research that I'm doing at the moment. So let's begin with what thinking is. So the model that I have on the screen here is a model from a very famous cognitive scientist called Dr. Willingham. And what he tells us is that thinking takes place in what he calls the working memory. And when we think, we use stimuli from the environment, which would basically be our senses. So that would be one source that we would use to think, and also information from our long-term memory. And that would include factual and procedural knowledge. Now, I could spend 5 minutes trying to explain that model, but I think the best way to understand it is to do some thinking. So here's your chance to participate. I found this puzzle on Facebook. I keep getting these sort of puzzles. I think probably because I keep answering them. And basically what you have to do is you have to work out what the question mark represents, which number. Now, several parents answered this correctly in the workshop. What I'm going to do is I'm going to leave a 10-second gap. So what I suggest is that you stop the video now and then start playing again when you have solved the puzzle, and good luck. Okay, welcome back again. And hopefully you had the number 23. So congratulations if you got that number. If you didn't, thanks for having a go. These puzzles are pretty tricky. So how do we get the number 23? Well, if we look at the stars at the top, each star has 6 points, and so each point represents 1. So 6 and 6 and 6 is 18. Each blade of the fan is worth 1. So 4 plus 4 plus 6 is 14. The 3 o'clock represents 3. So 3 plus 3 is 6 minus 4 is 2. And the bottom row, this is a tricky one. So we got two 5-pointed stars multiplied by 2, 20 plus 3, 23. Now let's have a look at that in a bit more depth and apply the model of thinking to that puzzle. So how did we solve it? Well, to begin with, we used information from the environment. We used our sense of sight to take in information. We used facts from our long-term memory. For example, if you knew that 18 divided by 3 was 6, that would help. Also, if you knew BODMAS, which is the order of operations, so for the bottom row, if you knew that you multiply before you add, you would know that you do 2 times 20 plus 3, you don't do 3 plus 2 times 10. Okay, so getting the order correct is important, so that would come from facts that you know. And the final thing that would have helped you are procedures. So this is basically how to go about doing something. So if you've seen this kind of puzzle before, you would know that sometimes they try and trick you. So they changed, for example, the 6-sided star to a 5-sided star, or they changed the 3 to a 2. And this can catch people out sometimes. Okay, so what I'd like to do now is have a look at another puzzle, okay? Just to make it clear about how this model works. So this time we need to work out how many cubes are in the puzzle. So again, I'll leave a short gap. So if you press stop now, and when you're ready to play again, please press play, and good luck again. Right, so I hope you enjoyed that puzzle. And the answer this time was 80. So how do we get to 80? Well, the back row is 4 times 5, which is 20. And the second row also has 20. The third row has 2 missing, so that would be 18. The fourth row has 6 missing, so that would be 14. And the front row has 12 missing, so that would be 8. So you've got 20, 20, 18, 14, and 8. Now, that's quite a lot of information to hold in your working memory. So what happens sometimes when we have a puzzle like this is we get something called cognitive overload, which is when we've got so many bits of information in our minds, it's very difficult to think clearly. So what can we do to help us with cognitive overload and to stop it from happening? So facts from your long-term memory. If you know that 4 times 5 is 20 and you're not having to use up your working memory to solve that, that would make this much easier. Also, being able to add and perhaps knowing those additions as facts would also help. I think also procedures from long-term memory help here, because if you've seen this sort of puzzle before, one strategy that you can use is to think of the cube as a whole cube, which would be 4 times 5 times 5, which would be 100, and then take away the missing bits. So 100 take away 2, take away 6, take away 12 would be 80, and that could be an easier way to solve this. But would you solve it that way without having some kind of knowledge of this kind of problem? Possibly not. So what Dr. Willingham tells us is that our working memories, which is where thinking takes place, have limited space. Many cognitive scientists say we can store perhaps, or we can hold 4 to 7 pieces of information in our working memories. And if we have more information than that, then we start to get cognitive overload, and that makes thinking difficult. So I quite like this quote from Dr. Willingham. He says that one way to cheat the limited size of your working memory is to use facts, and by having facts, we can use more of the space in our working memory to solving the problem, rather than having to think about, oh, what's 4 times 5, what's that plus that. We can think, we get more space in our working memories to solve the problem. So if you want to think clearly, one thing that we can use to help us are facts in our long-term memory. And as Dr. Willingham says, thinking well requires facts. Now, I'm going to look at a couple of examples now of why knowledge is important. I remember, it must be about 12 years ago, I was getting some training from, it was at another school, and I was told that facts are not important. You can just look them up. Well, that was kind of, I did hear that from a few people, but if we look at what cognitive research tells us, that absolutely is not the case. Facts and knowledge are critical to thinking. I quite like this example. So this is what happened in this example was Dr. William gave a group of Year 7 children a reading comprehension. And some of the children were above average readers, and some of the children had below average reading skills for that age. And he gave them all the same reading comprehension and the same questions. And these are the results. So which group performed the best? Well, not surprisingly, the children with the best reading skills, but also the ones that had knowledge of what the reading comprehension text was about. And in this case, it was baseball. The children who performed second best were the weaker readers who happened to know a lot of knowledge about baseball. They outperformed the children who had better reading skills and didn't know very much about baseball. And the children that got the lowest scores were the children with the weakest reading skills, but also had the lowest amount of knowledge about baseball. So what does this tell us? Well, if you could compare reading skills with knowledge about what you're reading, what he's suggesting here is that knowledge is very important if we want to understand the text that we're reading, having some kind of background knowledge. I think if we look at an excerpt from the text, it shows us why that might be, because if you don't, I don't know much about baseball, but I can see some words here: ground ball, shortstop, second baseman, on the bag. I could be very confused with what these terms mean, and a lot of my working memory could be taken up by trying to work out what these things mean. Whereas a person that knew something about baseball, but perhaps had weaker reading skills, would have a better understanding of this text because of the facts that they have in their long-term memory. So what Dr. Willingham says is that background knowledge creates extra room in your working memory, and it helps us to understand things. They can help us to understand things. And as I just said, it didn't matter whether the children were good or bad readers. The most important criterion for understanding the text was what they knew about the subject they were reading. I was thinking of an example earlier, actually. I'm reading War Horse with my children. And, my children are 11 months apart, similar reading ability. But my daughter, who is in Year 6 and is currently learning about the First World War, which is what War Horse is about, she has a much better understanding of the text than my son, who doesn't know anything about the First World War. And he's kind of missing quite a lot of the references in the text. So it's quite interesting to compare how background knowledge could affect a child's understanding. Now, the second example of the importance of knowledge is something called the Matthew effect. And this is something that I believe it comes from a passage in the Bible, but it's something that can be applied to many things in life. It is the rich get richer and the poor get poorer. So let's apply that to knowledge. So I won't go through all this data, but basically what it tells us is that somebody with more facts in their memory will learn more than somebody that has fewer facts. And the gap between the person who has more facts will grow at a kind of exponential rate. The gap gets wider and wider. So if we want our children to learn more, they need to have more facts in their memory to start off with. And, I think this is maybe in the long term, if you think about online learning and some children in schools around the world not really accessing that learning, and other children taking part in online learning. The gap between these children is going to be huge in the future. So, I really feel that encouraging your children to participate in online lessons is really vital. I like these two quotes. We got Einstein here, very famous quote: "Imagination is more important than knowledge." Well, what Dr. Willingham is suggesting is that Einstein might be wrong here. Nobody's saying that imagination isn't important, but he's saying that for us to imagine, a prerequisite for that is for us to have facts. The more facts and knowledge we have in our minds, the more imaginative we can be. I think it's quite. You could probably have a long discussion about that. I think it's. I quite enjoyed those two quotes anyway. And another great expert on knowledge, of course, is the Cat in the Hat. And what does the Cat in the Hat tell us? Well, the more you read, the more things you will know. The more that you learn, the more places you will go. So you could think about that literally, but if you think about it a bit more metaphorically, you can go more places perhaps in your mind using your imagination. You can be more creative if you have facts and knowledge at your fingertips to aid you. So that's how I would read that. Perhaps there are other interpretations, but I think it links nicely to what I'm talking about. Okay. So I stopped here during the presentation for some questions, but obviously this isn't live, so let's move on. Right, now the second part of the presentation is really about how you can help your children. I'm going to just share a quick anecdote with you. So about 2008, I think it was, I was working in Taiwan and I had a Year 5 class. And this is the only time I've ever done this. I took a class for 2 years in a row. So I was with them for Year 5 and Year 6. And in Year 5, they were amazing. They knew everything about the seasons, why we have seasons, Earth's rotation of the sun, tilt of the Earth. We made songs, we wrote about it, acted it out. I think we even had an assembly on it. So those children knew loads about this. 9 months later in Year 6, we were doing something in class, and I was bringing up the seasons, and I don't think that any child could remember why we had seasons. They were saying things like, "Oh, it's because the Earth is further away from the sun in the winter," and these kind of typical misconceptions. And I really had made a critical mistake. And that was that I had not given the children any opportunities to retrieve what they had previously learned. The children knew it 9 months previously, but and then they'd forgotten it. And I just assumed that they knew it and moved on. And this was a big mistake, because what I should have done, of course, is regularly give the children opportunities to retrieve and to remember what they have learned. And this is what we're going to be talking about for the next few minutes. So what is retrieval practice? Well, it's the act of retrieving from memory. It's not a new concept. Aristotle, what's that, 2,300 years ago approximately, said that exercise and repeatedly recalling a thing strengthens a memory. And there's a lot of research from cognitive science to say this is true. The more we repeat something, the more that we retrieve from our long-term memory, the stronger the connections in our mind become. And this is basically what retrieval practice is. And it's something that I know the primary are really focusing on, and the secondary school as well. Now, how can you help your children? Well, what can you do to, what examples are there of retrieval practice? The first one are flashcards. I was living in China about 23 years ago now, and I wanted to learn Mandarin. So I just used flashcards, was a really great aid to doing that. I had the word, I'm sure you know what flashcards are. You know, you get a pack of cards, maybe 50, 100, go through them, and it really helped me to learn vocabulary. And I think something else with this is that we can see on the right-hand side, we can see the word. I believe they're elements, yeah. And the child has drawn a picture, and we call this dual coding. So there are two ways that the children can help to remember. There's the word, but there's also the picture. And there's a lot of research to say that dual coding really helps people to remember things. Obviously, on the left, they're kind of probably produced by some kind of company, and on the right, the child's drawn their own. You know, perhaps making it more personal to yourself can help. I don't know of any particular research on that, but I do know that flashcards definitely help me when learning languages. I like this example. What the teacher's done here is to mix up some information. It looks like something to do with the Russian Revolution, I think. But they haven't just put recent information. They've got the distant past with the more recent past, and this is something called spacing, which we're going to be looking at in a minute. So, giving the children opportunity to retrieve what they know is very, very important, but also spacing it out over time. I'm going to look at another example of that in a minute. I quite like this. This is something quite easy to do. You know, say your child's learning, I just mentioned the First World War, and then I could ask my daughter, right, write down everything you know about the First World War, or the causes, or what life was like in the trenches, or, you know, there were different things that we could write down. And the act of children writing down what they know and retrieving that information from their memories will very much strengthen their memories. Now, this is a really great development in primary. We've been looking at knowledge organisers in primary, and this is an example from science. So basically, this has all of the key information that a child will need to know in the forthcoming topic that they're learning. So this is electricity. So we've actually just finished this unit, but I gave it to the children at the start of the unit. Parents know what their children are going to be learning about. Children can use it to revise, and all of the important things are there. And, you know, every subject is doing this in primary. And another thing I like about it is that it has the same format. So whether you look at a knowledge organizer in science or English or maths or music, etc., it's going to be green, orange, well, whatever the colors are. Vocabulary on the left, core knowledge, it's going to have the same format. And research tells us that children having a similar format reduces cognitive overload. So there is a reason why we've done that. If every knowledge organizer looked completely different, that could be confusing. We want to make things simpler so the children can focus on the important things, which isn't understanding the format, it's learning the vocabulary and the key skills. I always like using mnemonics with children. And I use that one myself at the top. I can never remember how many days there are in a month. So out come the knuckles. And once you know how to do that, it's quite an easy way to remember. Spellings, I mean, we often use mnemonics in spelling. It's never believe a lie. But there are hundreds of mnemonics like that you can use. We've got the planets and the order of the colors in the spectrum, but there are loads of these that you can use. And if you just search for mnemonics on any subject, I'm sure you'll find lots of examples on the internet. Right, so so I mentioned spaced practice earlier. So all the cognitive research that I've read about this is a real key feature, and that is that when you ask children to retrieve their knowledge, it should be spaced over time. Perhaps a 1 week gap or 2 week gaps, but there should be little and often, I think, is the key thing with this. So say, for example, a typical science lesson or typical maths lesson at school in primary, we would, the first 5 minutes, we're asking the children to recall previously learned information. It could be information from the first term, it could be from the previous week, but it's important that they have that opportunity to strengthen the memories. I quite like this diagram here. What's happening here is at the top, and this would have been me in about 1990. My test is on the 22nd. Well, 4 hours, maybe more like 8 hours. I'm going to stay up all night and try and remember everything. A really, really terrible strategy. What I should have done, of course, is the test is on the 22nd. I'm going to plan 30 minutes a day, little and often, to try and remember the information that I need to know for that test. And, you know I was speaking to Mrs. LaFrance, and she was telling me how secondary are giving the children a lot of information and practice, and encouraging children to take this strategy, not the staying up all night and drinking coffee strategy. Another thing about retrieval practice is that it shouldn't be too easy. I quite like this quote here from Brown et al. And inverse relationship. There's an inverse relationship between the ease of retrieval practice and the retention of knowledge. So if we need to find a kind of Goldilocks zone where it's not too easy and not too hard, because if it's too hard, then that's going to not be very motivating. But if it's too easy, then we can't strengthen the memories. So in our long-term memory. So, you know, it's about finding something that's a bit tricky. It's challenging, but not too challenging and not too easy. Okay, and you know, giving children time here. Don't expect them to do something really quickly. Make it a little bit challenging and give them an opportunity to think about it. Another feature of retrieval practice is practicing more than one subjects at once. So it says that research unequivocally shows that mastery and long-term retention are much better if you interleave. So I like this example of interleaving. If we're practicing maths concepts, if we just gave the children, right, we're doing multiplication, here are 17 multiplication questions, not a good strategy. Much better to mix it up. So let's do some multiplication, but let's mix it up with some addition, some subtraction. So the reason for this is to do with the concepts of discrimination. So children need to be able to discriminate between subtle differences. Another point about interleaving here is that research isn't saying that if you want to kind of strengthen your long-term memories about, say, I don't know, chemistry, then we don't mix chemistry up with Arabic, or chemistry and perhaps music. These two things are very different, all right? So there must be a close relationship between the difference. It shouldn't be a very wide difference. I think that's what I'm trying to say. So as in the previous page, mixing up addition and subtraction, that's a subtle difference. Mixing up French, the past, practicing past tense verbs in French and the 7 times table doesn't really have a connection, so that wouldn't be a good strategy. I believe a lot of the research on this comes from sport. So I remember when I used to play golf and I go to the driving range and just practice, I'm going to hit my 5 iron today. Again, research tells us that isn't a very good strategy. Better to mix up your irons, short irons, long irons, driver, not just to do one thing. So we could apply this having a game of tennis. Don't just practice your serve for an hour. Practice your serve for 5 minutes, then some volleys, then a bit of this and a bit of that, okay? And research tells us that is a much better strategy. One very important strategy that we can use to help our children is feedback. So here's some interleaving practice again with some different concepts mixed up. But if a child doesn't know it, then it's important to show them what the correct, how to answer the question, basically, if they can't do it. So, you know, feedback here is critical to help our children remember more. Now, I'll upload this presentation later because I can't share it with you. But the basically, there's a very good website here, retrievalpractice.org, and a lot of the research that I'm talking about is available on this website and in various books that are on that website. Right, well, I'm afraid I can't answer any questions because I'm not live. So I'd just like to leave it there. So I'd like to thank you for your time. I hope some of the things that I've talked about are helpful. If you do watch this video, feel free to email me if you have any questions or any feedback at all. It's mfag@bisr.com.sa. And just finally, I would really appreciate some help with some research I'm doing. So there's a very short questionnaire. So when I upload this video, I'm going to put the link to the questionnaire on the Parental Workshop Hub. Okay, so thank you for your time. I look forward to hearing from you if you have any questions, and thank you very much.